Hi, this is third video on Ngspice. In the last two tutorials, we saw how we can write Ngspice code for a RC network and half-wave rectifier. In this, we are going to plot transfer characteristic of a NPN transistor using Ngspice code. You can see here in the diagram, Vin is the input supply, VCC is the supply for the collector terminal, and we have added one dummy source, voltage source, because in Ngspice we cannot plot current through a component unless it is a voltage source. So that's why we have added a dummy voltage source with value 0 volt. So current through this voltage source is nothing but IC. So finally we would like to plot IC versus different VBE. So that's why we have added one dummy source. So let's write code for this. So we'll name transistor, Vim transistor. I'm using Vim text editor .cir. As usual, first line is the comment. So transfer characteristic. Transfer characteristics of BJT. I have numbered each nodes. You can see 1, 2, 3, 4 and 5, and values also I have mentioned here. This resistor value 50 kilo ohm, this resistor value 1 kilo, and this power supply 10 volt, and this is 0.8 volt. Let us start from this V in. So V in, syntax is V and the name of the voltage source between 1 and 0 and value of the 0.8 volt. Second one is the resistor. So it is RB in between 1 and 2 and value is 50k. Third one is the BJT. For that, syntax is given here. Q name, collector, base, emitter terminal and name of the BJT. So it should start from Q. So let me call it as a Q1, and I have to write first collector terminal. Collector terminal is 3 and base terminal is 2 and emitter is 0, and you have to write the name for BJT. I will write my BJT, any name you can give, and we have to define this BJT later using dot model statement. So next one is the dummy voltage source. I will call V dummy between 4 and 3. 4 and 3 value is 0. Next one is the resistor RC between 5 and 4. Its value 1k. And finally VCC. We will call it as VCC itself. VCC, and it is between 5 and 0. Value is 10. I think we have defined all the components. 1, 2, 3, 4, 5, 6 components. Yes, 6 statements. Next one is the model statement. The syntax is given here. Model name of the BJT. In this case, it is my BJT. NPN. Since it's a NPN BJT, we have to mention NPN. If it is a PNP, then we have to clearly mention PNP. And the parameters. This also you can refer any SPICE manual. We can define many parameters, but I have taken only 3, and I have not considered any junction capacitor because we would like to plot DC characteristics. So I have taken only these 3. To refer any SPICE manual, you will find what are the parameters we can give. So dot model name of the NPN, that is my BJT, and NPN, and IS is 1 e power minus 16. So 10 power minus 16 VJE is forward bias voltage across base and emitter junction, so that is 0.7. And BF, forward beta gain is 200. So, and we will end the code. We'll save it. So what we have defined? We have defined an input voltage source V in 10.8 RB between 1 and 250 kilo ohm. Q1, collector, base and emitter, name of the BJT, dummy voltage source, and a resistor and a power supply, and how to define a BJT model. Okay, let us run this and we will see any error in this, or can we directly plot the output characteristics, transfer characteristics. So I will write Ngspice and name of the code transistor .cir. You can see here circuit transfer characteristic of BJT. First line, that is nothing but the comment what we have given, same thing has come up here. That means it has successfully loaded the code. Let us try a DC analysis. So you have seen the transfer characteristic of BJT, where x-axis is VCE, y-axis is IC, and you will get multiple plots. Each plot belongs to a particular value of VBE. So we have to sweep two sources here. One is Vin, another one is VCC. So how to write that? The syntax is DC, and which voltage you would like to sweep first. We will like to sweep VCC, DC VCC, starting value that is 0 and end value is 10, and step size that is 1. So what does it mean? You are performing a DC analysis, you are varying VCC power supply from 0 volt to 10 volt in steps of 1. In the same line, you have to vary Vin also. So let us plot Vin also. Let us vary Vin also. But here we will vary from 0.7 because forward bias junction voltage is 0.7. So let us start with that value 0.7 to 0.8, and with the step of 0.01 if you may, and 10 values you will get. That is 71, 72, 73, 0.71, 0.72, like this we will get till 0.8. Or if you make 0.2, so in this case first one is 0.7, second value will be 0.72, 74, 76, 78 and 0.8. So let us see first that. So it has performed that analysis. Let us plot IC, but IC directly we cannot plot. Or what we can do is current flowing through the voltage source, that is dummy, that we can plot. V, and the name of the voltage source is V dummy. Yes, you can see here x-axis is nothing but VCE. How we got this VCE? That is, we have varied VCC from a minimum to maximum value. So that is VCC actually we have plotted on the x-axis, and in this y-axis is nothing but IC, but indirectly we plotted it is actually V dummy, but it is nothing but a collector current. And we have got multiple plots here. This is for when Vin equal to 0.7. This is second one is when Vin equal to 0.72, 74, 76, 78 and 0.8. So these are the plots we have obtained. So in this we have seen how we can plot transfer characteristic of BJT using Ngspice. Thank you.